In this video, we're going to talk about titrations. So what's a titration? Well, a titration is a method in which a solution with a known molarity is used to determine the molarity of an unknown solution. And we do this by finding the equivalence point. So the equivalence point, when we do a titration, is determined by a color change, and that represents a change in pH. So a solution with a pH less than 7 is acidic, and a solution with a pH greater than 7 is basic. So what's happening is we're taking a base, we're adding it to an acid, one drop at a time. As we add a base to an acid, remember, things that are basic have a pH greater than 7, our pH begins to increase, and when we reach a pH of 7, we reach the equivalence point, so that acid is essentially neutralized in this case. So here's an example. It says, what's the molarity of an unknown H2CO3 solution if 35 milliliters of 1.3 molar NaOH is needed to neutralize 15 milliliters of H2CO3? Okay, well, first thing we need to take care of is we have a volume that's given in milliliters. We need to convert this to liters. So we have 35 milliliters. And remember, we have 1,000 milliliters in 1 liter. So we'll have 0.035 liters here. And this is the NaOH. The NaOH has a molarity of 1.3, so 1.3 molar. And our H2CO3 the volume is also given in milliliters, so we need to convert that to liters. Okay, so we don't know the molarity here. Okay, so step one, let's take our known molarity and our known volume and find the moles. So we'll use our molarity equation here. So we have a molarity of 1.3 molar. We don't know the moles, and the volume is 0.035 liters. So when we do the math here, we get 0.0455 moles of NaOH. Okay, so we're going from NaOH to H2CO3. So we're going to do a mole ratio here. So step 2 is a mole ratio. So 0.0455 moles of NaOH. And looking at our equation here, there are 2 moles of NaOH for every 1 mole of H2CO3. And when we do the math, we get 0.02275 moles of H2CO3. Okay, our last step, because we're trying to find the molarity here, is we're going to take the moles of our H2CO3 and we're going to turn this back into concentration, a molarity. So molarity is equal to moles over liters. So remember, we know the volume here. We know the volume. We now have the number of moles. We're trying to find molarity. So let's just plug in what we've got. So our moles are 0.02275. And our volume that we found at the beginning in liters, 0.015 liters. So we get 1.5166, and all of the numbers in our question are in 2 sig figs. So when we get our final answer here, it's going to be 1.5 molar. So the concentration of our H2CO3, 1.5 molar. All right, let's take a look at another example here. So it takes 7.3 milliliters of 1.25 molar HNO3 to neutralize 25 milliliters of BaOH2. What's the molarity of BaOH2? So again, let's figure out what we've got. So we've got HNO3. So it tells us that it's got a molarity of 1.25 molar. It also tells us that we have 7.3 milliliters. So we need to convert that to liters. So that's 0.0073 liters. And then we also have BaOH2. So we don't have a molarity. And our volume is 25 milliliters, which if you convert, that's 0.025 liters. Okay, step 1, we need to find the moles of our HNO3. So molarity is equal to moles over liters. So 1.25 molar is equal to moles over liters, 0.0073 liters. So we get our moles are equal to 0.009125 moles. Step 2 is going to be that mole ratio. So we're going HNO3 to BaOH2. So we have 0.009125 moles of HNO3. And our mole ratio here is 2 moles HNO3 to 1 mole BaOH2. So we do the math, 0.0045625 moles of BaOH2. And then our last step is just to plug into that molarity equation. So moles over liters. This time we're using the BaOH2. So our moles are 0.004625 moles over our volume, which is right here, 0.025 liters. So when you do the numbers here, you get 0.1825. And looking at our question, all of our numbers, except for one, have 2 sig figs, and that other number has 3, so we'll go with 2 sig figs here. So our final answer will be 0.18 molar. And those are titrations.